Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Mevis, for this episode of CompTIA Linux Plus. Linux file systems, that's what we're looking at today with Don Pezet, our expert. Don, good to see you. Thanks for being here.
Glad to be back. And you know, Linux file system is actually a pretty big topic for us to cover, so we're going to try and get through it all here in one episode. But in the previous episode, we created some partitions. And partitions are great because it divides up our hard drive and lets us put data on it. But we can't use the partitions until we put a file system on there, something to track where all the file data is stored. So in this episode, what we're going to do is learn about some of the different file systems that are out there, kind of help us decide which one is right for our solution. And then we're going to see applying that file system to some partitions. And then we're going to wrap up this episode by seeing how to mount the partitions and bring them online so we can actually start to use them and then put files in there and, you know, do all the stuff that we pay for when we buy a hard drive. So that's all coming up right here in this episode.
Well, Don, how do we choose which file system to use?
All right. Well, you know, picking a file system is a big decision because when you have a brand new hard drive or a disk you've just formatted, it's easy for you to put a file system on it. But the moment you start putting data on there, you can't really change the file system anymore. You'd have to back up your data, reformat the drive, and then put your data back on there. That's not exactly an easy thing to do, or is it a fun thing? So it's a big decision. We want to make sure we're making the right decision from the very beginning. And when you're installing Linux, this is a decision you'll make. It'll either have a default file system that it uses, or you'll override that and choose a file system. And different Linux distros actually have different defaults. So for example, if you install Ubuntu right now, and you just click next a bunch of times for the install, it's going to format your disks as ext4, the extended file system version 4, ext4. That's what they default to. But if you install CentOS right now, and you just click next a bunch of times, it's going to format your disks as XFS, a different file system, right? So different distros are picking different ones, and you'll see the most popular are ext3, ext4, XFS, BTRFS. But there's several others that are out there, like ZFS and well, even like FAT32 and some of the ones that come from other operating systems. Those file systems are oftentimes supported by Linux, but it doesn't necessarily mean you should pick them, right? You need to pick a file system that one, meets your needs, right? So it provides you the functionality that you need. Two, is supported by the operating system vendor because you need to make sure you've got that. And then three, is stable and mature and reliable. When you put data on a disk, you need to make sure that data is still there when you go to get it back again. And that's all stuff that's going to influence you as you make your decision. So let me run through a few, and I'm going to focus on just three, right? There's three really popular file systems right now, and that's EXT, XFS, and BTRFS, those three. The other ones, like ZFS. ZFS has a strong following behind it. It's wrapped up in a weird BSD license that a lot of operating systems aren't friendly with, so you don't see it everywhere. Your system may or may not support it. But with ZFS, it's really designed for network storage appliances or clusters that are doing shared storage across nodes. GlusterFS is another one that's like that. Those are not really all that common. On the common side, we're going to see, well, the main one is EXT. EXT is a file system that's been around in the Linux and Unix world for a long, long time. So remember I said you want to find a file system that's mature? It's hard to find one that's more mature than EXT. We're currently on version 4. Well, EXT hasn't actually changed all that much over the years. They've just added more features to it to increase its stability. So, for example, with ext3, you had support for quite a few things. You could have thousands of folders, millions of files. You could have file sizes that were gigantic. You'd have file names that were gigantic. These are all really nice things to have. But it did suffer a little bit in that if you had like a power outage, you could be partially writing files to the disk and the file might end up getting corrupted, right? Power outages could do that. Well, with ext4, they added journaling support by default. You actually had journaling support kind of as an option in 3, but it was enabled by default in 4. And with journaling support, what it does is it says, hey, when you write to the hard drive, instead of writing directly to the file you're writing to, you'll write to a second place on the disk. And only when you're 100% done writing do we swap around and that becomes the new version of the file and we delete the old version. That way, if there's a power outage while you're halfway writing, you're okay because the original file is still intact. So that makes ext4 far more stable and safe. So it's a neat file system. EXT is supported by pretty much every Linux distro. I don't think I've ever encountered a Linux distro that didn't support EXT. At a minimum, they're going to support EXT3, which is capable of reading ext4 without the journaling. So, if you want those features, though, it's usually just a matter of a driver away. And once you've got that, you've got the support. So if you want to pick something that you know is common and safe, that is reliable, ext4 is a great choice. All right. That being said, the folks over at Red Hat adopted a different file system for their default. They adopted XFS. And XFS is the extended file system, is what it stands for. And it is very, very similar to ext4. They're not directly compatible, though. So, for example, it's a different file driver that we use to read XFS than ext4. And with XFS, it has a lot of the same features. It has journaling support. It has support for long file names, for thousands upon thousands of folders and millions upon millions of files. It's got a lot of support for that. It's designed to be the successor to EXT. It has support for some really interesting things, like the ability to resize a partition, which we can get another way. We're going to learn about in another episode, a system called the LVM, the Logical Volume Manager, and it makes resizing and stuff a heck of a lot easier. But XFS has a bit of support for that. It incorporates journaling. I already mentioned you can grow and shrink your partitions. So it's a very trusted file system. It's got the backing of Red Hat, which means you've got a commercial entity that's financially invested in that file system. So you know that it's going to be stable and it's going to be well supported. Okay. The third one that I mentioned was BTRFS, which stands for the Better File System. And some people say it's the joke is that it's the butter file system because it's smooth as butter.
It's butter.
I don't really get that
It's like
analogy.
butter.
But that's what they say.
Yeah.
But it actually stands for the Better File System. It was designed to incorporate a ton of features that are pretty advanced, right? So, I mean, it has things like journaling, long file support, all the stuff we saw in the other file systems. But they incorporated a lot of functionality that we're going to learn about in the LVM show. The LVM Logical Volume Manager lets you slice up drives and glue them back together and rearrange storage, all without affecting the underlying data. BTRFS can do all that too. All right. Here's the thing. Some of the features in BTRFS are a little bit cutting edge, like the software RAID functionality. It can do RAID 0, RAID 1, even RAID 5. But there are numerous data loss scenarios with BTRFS. In other words, there's scenarios where you could actually lose your data if you're running BTRFS. And as a result, most of the commercial vendors out there, like Red Hat will not support BTRFS. In fact, in the latest versions with Red Hat, with RHEL 7.4, I think is where they made the change. And they've announced it's going forward into RHEL 8, that it's not even an option to do BTRFS in the installer anymore. You at least had the option before, but it said unsupported. Now they've even removed that. Ubuntu, they still support BTRFS. You can still choose it during the installer, but I'll be honest with you, I would never run a file system that had known data loss scenarios. And I also would never do software RAID, right? So if you want RAID, you get a hardware RAID controller. They're not that expensive. So that's the better way to handle that. And that's the way a lot of commercial vendors are going to look at it. Now at home, maybe you want some RAID functionality. You don't want to use LVM and you aren't worried about losing a little data. Maybe you back up to the cloud so you're fine. So you could leverage BTRFS, but that one's not going to be as popular. It is widely viewed, though, that BTRFS is the way of the future. That when I film this show 5 years from now, I might be saying something completely different. Like, hey, BTRFS is the greatest file system ever. This is the one you want. You can run an antique like XFS, but this is the one. But today, it's not like that. So in a commercial environment, you're usually picking between ext4 and XFS. And I'll tell you, once the systems are formatted, ext4 and XFS basically function the same. It's hard to spot a real difference once you're in there. I'm a Red Hat guy. I use Red Hat, CentOS, Fedora, and so I usually go with XFS because it's easier when I call them for support. But if I'm dealing with other systems, like if I'm moving data between a Red Hat system and Mac or Ubuntu or Debian or something like that, I'll usually format ext4 to make it a little easier for me to carry that data between the systems, a little more compatible. So those are the file systems that we need to be aware of. And as far as choosing a right or a wrong one, there really isn't a right or wrong. It's just based on your needs. What you need is going to determine the file system that you pick.
So, Don, what tool do we use to actually create the file system?
All right. The tool that we're going to use is a utility called MKFS, or Make File System. MKFS is included with pretty much every Linux distro that's out there. But you will see a little bit of variation with MakeFS on your system or any system, really. we don't necessarily know from distro to distro which file systems they support. And with MKFS, there's a command line tag we use with it, -T, where you specify the file system type, what you're going to use. So you'd specify ext4 or you'd specify XFS. Well, a lot of operating systems will start to include aliases for MKFS to help you know what they support. Let me show you what I mean, because this is easier seen than said. So I'm on a CentOS box here. I'm going to open up a terminal. And if I do man MKFS, right? So that's going to show me the help file for your make file system. And here it says MKFS builds a Linux file system. And if we read through, we'll see that we have an option to specify a type. So -T and what file system we want to go with, right? Well, if you scroll through here and look at the man page, it tells you, yeah, use -T. But then it doesn't really tell you anything besides what the default would be. And the default here is ext2, which is pretty old, right? But looking beyond, which file systems does it support? Well, right down here, I can see that there's a bunch of aliases for MKFS. See how there's mkfs.bfs, mkfs.ext2, 3, 4, mkfs.minix. Those are aliases that designate the type and say we can format, if we want to format it to the Minix format, I can do mkfs.minix and it will do that. That's the same thing as if I typed mkfs-t minix. But the way I use this is if I ever want to know what file systems are supported, I'll pull up a listing of /user/sbin/mkfs star. So if you pull up that listing and look, you'll see all the aliases. So I can see BTRFS. I've got it right there. I could run that if I wanted. ext2, 3, and 4. I've got XFS over here. VFAT, FAT, which is it says FAT, but it's actually the FAT32 from Microsoft. And let's see, CramFS is another one that's in here. Now, I don't see some other ones that maybe I want, like NTFS is not here. So if I want to mount an NTFS disk, I'd have to go and get a driver for it. I can't actually make that file system here. But these are the ones that my distro supports. If you're running the same command on Ubuntu or on some other system, you may see different commands that are available, or you might not see any aliases at all. You might just see MKFS, and now you got to go and read the documentation to figure out what's supported. But that's the tool that we're going to use. And the tool itself is actually pretty straightforward. You do need to be an administrator to run it. So you'll use the sudo command, and then you'll do sudo mkfs dot, and then the file system you're picking. So maybe I'm going to do ext4. And then you point at the disk that you want to format. So, I don't actually know what disk I'm going to do. Let's do lsblk to list my block devices. And I've got a couple of partitions on my SDB disk. So SDB 1, 2, and 3. I've got a couple of 256 gig partitions there. I want to format them. So what I can do is do a sudo mkfs.ext4. And I'm going to point that at /dev/sdb1, and that's going to format that first partition as ext4. And when I run it, I'll see that it's building that file system. It's identifying how many inodes it has. It lays all that out, and then it writes the file system to it. That means it's creating a file system table at the very beginning and mapping how it's going to keep track of what file names are in what folders and where the actual binary data is going to get stored. If I wanted to do XFS, I would just change the command a little bit here. I'm going to format SDB2 as XFS. And so I'll pick that one and I run it. Notice how the output looks a little different because XFS works a little bit different, but it still formats and applies. And now that second partition is flagged as XFS. So once they're done, once they're formatted, I'm really going to treat these two partitions the same way. For the whole rest of the show, I'll work with SDB 1 and 2, and I'll really just treat them equally, even though they're different file systems. There'll be subtle characteristics that are different between them. Maybe some feature is supported on one and not on the other. I might have to use different commands to apply something like a label, but otherwise I'm going to treat them the same. Now, there is one more file system I haven't mentioned that I want to highlight here real quick, and that's if you created a swap partition. All right, I have a swap partition on mine. If I do let me do fdisk, oops, I can't spell it, fdisk/dev/sdb, and I take a look here. So I've got a 4 gig partition, SDB3, and the file system type has been set to Linux swap, right? So it's going to be a swap partition. Well, what file system do we put on a swap drive? We actually don't. We don't put XFS or ext4 or whatever, because it's going to be storing what's basically virtual memory or raw bits that would normally be stored in RAM. So this one's a little bit different because it's not a native file system. It's not normal like we would. So we actually have a special utility to format that one. If you have a swap partition, you're going to use a utility called mkswap. So instead of mkfs, we're not making a file system, we're making swap storage. And we'll point that at /dev/sdb3. That's my third partition. And when I run that, it's going to basically apply a format, right? Like applying a file system, but it's the swap one, and it puts it in there. Now, that doesn't actually go active right away. The swap partition is now ready to be used. We have to tell the system to use it. I'm going to say sudo swap on, and then I'll point to /dev/sdb3. And that's going to tell the system, hey, here's this new partition that has a space that's reserved for swap memory. Go ahead and use it. And then I'll add it to my virtual memory block. And I just added 4 gigs of memory to my system. Not 4 gigs of fast memory, right? It's 4 gigs of, well, in my case, it's SSD. It won't be so bad, but it's still not going to be as fast as my RAM. But now it's enabled and it's on. So that's kind of an extra file system we need to be aware of.
Well, can we change the file system after it's created?
Sort of. It's really hard to change the file system. Basically, you need to reformat. And when you reformat, you lose all the data that's on the disk.
Oh,
so
no.
that second disk that I formatted XFS, let's say I change my mind. I say, you know what? No, I'm going to go all ext4. Well, if I run mkfs.ext4 and I point that at that disk, it's going to erase everything that's on it. So I would need to back up my data, go ahead and erase it with the new file system, and then restore all my data. And that's a pain, right? So we don't normally change file systems. There are some exceptions, like if you're running ext2, ext3 is really just an extension. And then if you're running ext3, ext4 is really just an extension. So you can actually convert a disk. ext4 is really just ext3 with journaling turned on. So you can enable that. And there's utilities that let you manipulate it. Depending on which file system you're running, there's usually these tune commands. Let's see if I can spot some of those. They'll usually be in /usr/sbin. I'll just look for tune star. There we go. So on mine, and you might see something different on yours, I have, for example, tune2fs, right? And that's for tuning or tweaking the ext2 file system. And although it's got 2 in the name, you can actually use it to manipulate ext3 and ext4 partitions as well, because they're all ext, just with different feature sets. So I could use that to change some behaviors of the file system. Usually, the only thing that I ever go back and change on these that doesn't really require format is assigning a label. Labels can be really convenient to help us identify disks and make sure they're mounted when your system boots up and so on. Labels are easy to change after the fact. They're really easy in the GUI. From the command line, it's going to depend on which file system we picked. So for example, let me come back in here. And if you just do a search inside of /user/sbin for E2, you'll see there's a bunch of E2 commands that are available, like E2 label, that we can use to change the disk label of an ext2, 3, or 4 system. All right. We also have other commands, like if I look for *xfs*, I have a bunch of XFS utilities that I can use to manipulate it, and most of them focus on things like resizing or deleting, taking a snapshot, and so on. But if you poke around in here somewhere, you'll find XFS admin, which there, okay, had a hard time finding it. That one right there, which we can use to assign labels. So let me just show you real quick. We'll stick some labels on these. So I'm going to do a sudo e2 label /dev/sdb1. And I'm going to give it a label. Maybe I want to use this one as my, I'll call it public storage. All right, so this is going to be public storage that I share with other people. So I just assigned a label to it. If I want to do that for SDB2, then that's going to be a little bit different. I need to use XFS admin for that one. So I'll say sudo XFS_admin -L. It's a capital L, and I'm assigning a label. And the label for this one is going to be private storage. And then I point it at /dev/sdb2. And because it's my title is a little too long. So it shortened it for me there. I lost 2 characters. But anyhow, it assigns that label, and now SDB2 has it. So each one behaves a little bit different. I'm trying to see here. Oh, yeah, it had 2 more characters in with E2, so I lucked out. Maybe I'll just label them. I'm going to change the label name. Easy enough. I'm just going to call them private and public. That'll be a little bit easier to remember too. And right there. Okay. So now I've assigned some labels to those disks, and that's non-destructive. I can have all the data on those disks that I want, and it doesn't mess with them. Now they've got some labels. That'll be really handy later on, because when I'm mounting disks, for example, maybe I can't remember. Was it SD1, SDB1, SDB2? You know, how do you keep track of all that? I can just remember the label. Oh, somewhere on my computer there's a disk named private, and somewhere on my computer there's a disk named public. And so when I mount them, I can mount them based on that label name, and life becomes a lot easier. So those are examples of some of the things that we can change after a file system is created.
So how do we start using the new file system, Don?
All right, so we've made our file systems. We formatted those disks, right? They're online technically, but I've got no way to get into them, right? You can't actually use a disk until it's mounted somewhere on your system. In the Unix world, and thus in the Linux world, practically everything is treated like a file. And so these partitions need to be mounted into the file system so that we can browse and find them. And they need to be in our directory tree. So we actually had that with a lot of stuff already. If you just type the word mount on your computer, just type mount and press enter, right? You don't have to be an admin for this one. It's going to give you a list of all the disks on your system and where they're mounted. And you might see a lot of stuff here, a lot of stuff that you've never even noticed because the operating system creates things when it installs. And if you've got the LVM, you'll have a ton of things. But a lot of them are pretty easy to read. Like you can see right here in this section where I've got /dev/SDA 1, 2, 5, and 6. And they're mounted to /opt, /home, /boot, /var/log, those locations. If I browse that spot on the disk, I'm actually moving between partitions. I don't realize that. You know, when I'm in the root, I'm in one partition, and then when I go into the home folder, I just moved into a whole new partition, right? But we don't really see that. That's kind of hidden from us, but it is actually happening. And if you were to do a df-h, that shows you, you know, your hard drives and how full they are. And I can see all of those different mount points. And so when I look at the root, it's got 50 gigs of storage. But when I look at /home, it's got 400 gigs of storage, right? Separate partitions with separate storage. We need to take those two disks that we just formatted, and we need to mount them in the file system here so that we can access them. So the way we're going to do that is by using that mount command. Mount will let you see the disk, but it'll also let you actually mount them. If you pull up the man file for it, it has a ton of options. It's a very intimidating command, but it's actually gotten a heck of a lot easier. Back in the day, right? So if we were doing this 10 years ago, the mount command was super frustrating because you had to know exactly what file system was on the media, and then you had to specify where you were going to be mounting it to. Well, now Mount does automatic detection. It will figure out what the file system is for you. So now it becomes really easy. You just need to tell it what device is going to be mounted where. In order to do that, you need to create some folders to mount to. Okay, so I'm going to mount it somewhere. I need to have a folder. By default, it's going to mount to all sorts of crazy places. You'll see like here in CentOS, and actually Ubuntu does this as well. If you put a CD in, it'll auto mount the CD, and it'll put it in /run, /media, whatever your username is, and then the name of that disk. For me, that's always a little bit complex. It's just like a long path. So a lot of older Unix administrators will follow the old standard where we mount things in the MNT folder. When you look at your root, there's a folder in there called MNT, and that's where you mount things. Now, this MNT folder is designed for mounting things that will usually be available to the entire system, not necessarily for an individual user. If you want to mount something to an individual user, you can put it inside of their home directory, and now it's available just to them. They can navigate into that. But in my case, I'm going to use mount. And inside of the mount folder, I'm just going to do cd mnt. I'm going to create two directories. I'm going to create one called private, and whoops, I do need to be an administrator to do that. And I'll create another one called public. So sudo mkdir private and public. I actually could have done that in one line if I did the name separated by a space. But anyhow, so now I've got two folders right here. They're just regular old folders. But I'm going to mount those partitions to the folder so that when we navigate inside of them, we're going to see available storage, right? Right now, I don't have that. These are just part of the root folder, and so they'll have 50 gigs of storage available. But when I mount them to those partitions, I think my partitions are 250 gigs each, so they'll now have that dedicated space to them. So the way we do that, the way we actually mount these things, is we type sudo mount, and I have to sudo it. I'll show you a way that we can kind of get around that later. But so I'm going to sudo the mount command, and then I specify the device that I want to mount. So the first one I did was SDB1, and that was my public disk, right? The one that I wanted to share with everybody. So I'm going to mount that to /mnt/public. All right, and the commands are case sensitive, so I did a capital P earlier. I'm going to stick with the capital P now. And then I'm going to mount SDB2 to private. Now, one of them is ext4, and the other is XFS. But I didn't have to specify that here, right? It automatically figured that out. And I can verify that by just running the mount command by itself. And when I look, I can find right here the two that I just mounted and see how it automatically detected one's ext4 and the other is XFS. So it figured that out and they're now available. And if I navigate into that folder, I don't realize it, but I just moved into a whole new partition. And if I do a df-h, I'll see the public and private folders right there and see how they both have 250 gigs of storage, right? They're not limited to what the root folder had before. Now they've got a full 250 gigs of storage each, and I can put all my public data in one, all my private in the other, and start to make use of them. It's all actually online for me to use now.
Will the file system still be mounted if we reboot, Don?
They won't. So it's a good question. What I just did right there is temporary, right? I just used the mount command. If I reboot right now, those are going to go away. Or if I want to unmount them, I could actually use the umount command. So umount, and then you point to /mnt/private or whatever, and it would unmount them. But a reboot will unmount all of them. So if we want this to be persistent, if we know we're going to be using these folders every single day or just using them a lot, then we need to make it persistent. And we do that by putting them into the file system table. We saw the file system table in an earlier episode, but we didn't really spend a lot of time on it. So let's do that now. On your system, you will have a file here. Let me list it. In /etc/fstab or fstab. And that's the file system table.
It's stabby.
It's stabby. So when we take a look at it, basically what it's doing is it's telling the system, hey, when you boot up, here's the different file systems that I want you to mount. And I don't see /private. I don't see /public. They're not showing up in there because they're not persistent. So when I boot up, though, it is going to mount /home and /op /var/log. It's going to mount each of those, right? Because it's been told to, all right? If I want public and private to be mounted every time I boot, I'm going to need to add them to this list. Now, you do need to be an administrator to edit this file, so I'm going to edit it. I'll do sudo, and you can use whatever editor you want to use. Maybe you're a nano person or Vi or whatever. I'm going to use Vi /etc/fstab. All right. When we go in here, we want to leave all the existing ones alone, right? Because they're kind of important if we want our system to boot every time. So I'm going to leave them be. And I'm going to add another line after here to map in our new stuff. Now, the disks that are here are mounted a few different ways. We actually have several different options for how we want to identify the disk that we're mounting. The best way to identify a disk is to use its UUID. When you format a disk, a UUID is displayed. In fact, mine, if we were to scroll back to where I created it, we would have seen the UUID there. Or we can use the BLK-ID command to pull it up and actually see it. LSBLK can show it as well. If you do, I think it's -V, you have to actually see it. So a few different ways to find that UUID. The nice thing about the UUID, if you change the label, if you remove the hard drive and move it to some other computer, the UUID always stays the same. And so you can ensure that you're mounting the right disk because of that UUID. The negative of them is that they're a long, scrambly number that nobody can ever remember. So when I look at these UUIDs, they don't mean anything to me. So I prefer to either use the device name, which we actually see an example of right here, where it's mapping this /dev/mapper. I can mount /dev/sdb1 and then mount that to a folder, right? So that's a little easy if we know our device name. But imagine if somebody moves a cable inside of the computer. Well, SDB1 might become SDC1 after they move the cable, and now it's not going to mount anymore. Well, I know I applied labels, so I could mount based on a label as well. So the way we do this, I'll show you both ways. So let's do it based on a device name. So based on the device name, I would say something like this, /dev/sdb1, that's my device. And then you can use your tab key to kind of advance. This whole thing, it's hard to keep it lined up and pretty like they're doing. It doesn't have to. Like Linux actually doesn't care at all about how this is formatted, but keeping it aligned makes things easier for you to support and troubleshoot. So I can mount this one to /mnt/public, like that. And then I need to tell it the file system. We don't get automatic file system detection here. Mine is ext4. And then I need to specify the options. Now, the options are a little weird. Notice how all these just say defaults. There's a ton of options. And I mentioned this in the permissions episode. If we want to use FACLs, right, file system ACLs, we need the ACL file system option turned on. Well, this just says defaults. That means whatever Red Hat or CentOS or Canonical, Debian, whatever they feel are the defaults, will run with that. Okay. If you ever want to see the defaults, we kind of already saw them. Well, they're off my screen now. I'll pull it up in a minute. When you just type the mount command and it shows you all the different file systems that are mounted, it had all the actual options laid out there, and those are the defaults. And we can override any number of them. I'll pull it up when I'm out of this file. The last set here are a little bit antiquated, but let me go all the way over here, and you'll see where it's got this 0, 0 at the end of it, seemingly kind of random, right? Well, they actually do mean something, and it depends. The first one actually isn't all that useful. The first one is either going to be a 0 or a 1, and it means if you run the dump utility, which is a very, very old backup utility, then this partition will be included in the backup. If it's a 0, when somebody runs the dump utility, it won't be included in the backup. Now, let me tell you guys something. Nobody uses the dump utility anymore. It is ancient. It's not great for backing up modern file systems. There's 100 other tools that are better. So that effectively makes this first number useless. So we're not really worried about that. The next number, though, identifies the order in which a disk would be checked in the event that a file system check occurs. Every now and then, at certain set intervals, when you boot up a Linux system, it'll run a file system check to look for any damaged files or data corruption or whatever. And when it does that, it starts with it starts with the boot partition because it's got to get that one functional. But then after that, it moves through these in order, doing the 0 drives first and the 1 drive second. All right. Well, the zeros, you'll notice here, every disk is flagged as a 0 because in Red Hat land, they're just saying, look, check them all, right? But you can actually manipulate and say, well, I don't want to check this one until maybe after boot because I want the system to start booting up, and this one isn't critical to boot. So I can make it a 1, and that way it could start checking it while the boot was still going on. Otherwise, the boot would stop while it waited to check all of these before advancing again. So this is something we can use to manipulate our boot process a little bit. Most people don't have to do it, though. So you can kind of mirror what's already in there, or you can just set it to 1, and it'll be a secondary kind of backup. Now, in this case, I used the device name. I had to remember that SDB1 was public, and I can guarantee you half an hour from now, I won't remember which one is public and which one is private. So instead of doing it that way, I could have said label equals private, like that. And now I'm saying, I don't care what the device ID is. Just look at the disk, and if its label says private, mount that to /mnt/private, okay? This is a neat option because what we can do is we can take any disk and apply that label to it, and it'll mount to the right location. So maybe I want to replace this disk. I can get an all-new disk, format it, copy the data over to it, and apply the same label. And then when I remount, it'll mount the new disk, because the old disk can go away, or I change the old disk label so it doesn't match anymore. So it's an easy way to do it and keep that straight. I like labels, except they can create a bit of a security concern because an attacker could come in with like a USB disk with the right label, and your system might mount it instead of an internal disk, and that can create some problems there. So security guys aren't a big fan of the label system. I'll tell you, if a hacker's able to plug a USB drive into your computer, you've got bigger problems than what a label is. But it is something to be aware of. Both of these options work, though. And now, when the system reboots, it's going to look at this file system table, and it's going to see my 2 new partitions, and it's going to make sure that they get booted. Or not they get booted, that they get mounted to the file system so that they'll be available. And so I'll go ahead and save that and get out. Also, by putting it in the file system table, now you don't have to be an administrator to mount them anymore. Somebody could type mount /mnt/private, and it'll mount it because it's a part of the file system. We bring it online. I mean, it should already be online, right? But at that point, it would mount it and make it available to people. So from there, we're in pretty good shape.
Awesome episode, Linux file systems. I have learned a lot. I'm sure you did too. Thanks for joining us. Anything else you'd like to say, Don, before we go on?
Experiment with the different file systems. I always recommend, you have a lot of choices with Linux. That's always a nice thing. But I recommend that you go with the default file system for the distro that you're choosing. You're going to get better support that way. It's going to be easier on you in the long run. But don't ignore the other file systems. BTRFS has some really neat features. GlusterFS has tons of crazy features inside of it. There's some really neat ones that are out there. If you're running a NAS, like a network storage box, ZFS has some real promise too. So get out there, experiment, check on them. On the exam, though, you're really going to be seeing ext4, XFS, and BTRFS. Those are kind of the 3 main ones.
Great stuff, Don, as usual. Thank you very much. CompTIA Linux Plus is a wonderful series. Make sure you watch each and every episode. It's going to be very helpful to you when that exam comes rolling along. And don't forget about the supplementary information that's in our course library that will do one thing, help you be even more successful. So check that out too. And tell everybody you know about IT Pro TV. You know IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again very soon.
Thank you for watching IT Pro TV.